This is IBM Museum. So just a really impromptu video, a little bit of a follow-up to running the UNPC CMOS viewer program or utility from the UNPC book. And I have the Model 60 behind me, and I've got to go through, and I was doing how the cable connection is done for the speaker and battery tower. And I've got to go through and get this back together. And I'll have to run through, since it was separated. I don't want to make any wires more taut than they are. Try and show this on screen. Just it goes underneath the this clip, and since I pulled the this out with the good battery in it, I've got to go through and reconfigure the system anyway. And I thought, well, I had a Model 60 planar out. I want to demonstrate on the so there, that assembly is back together. You know, for things like a Model 50 or 70, the long planars, that would go in that slot connection. But on the Model 60, Model 80, it's using this header. And there's 4 wires to this connection. So let me get that back in. And certainly I can go through and pause videos to get all this back together. But anyway, we saw in the Model 50 and 50Z, or at least the 50Z, I ran the CMOS viewing program on it, showing that it's what was supposed to be that extended microchannel or extended CMOS area for a microchannel system. And just getting that thing back in place, and it probably lost the config, so I'll have to go through. And I do have the all the diskettes that I came up with for configuring the 50Z. There I've got the reference diskette that's shared between the 50Z and Model 60. Even though I do have a separate diskette that I compiled before, this has the ADF for this memory adapter. The same memory adapter we had in slot 1 of the 50Z. We're going to install it in the bottommost slot, slot 1 of the of this system. And I do have, I have the SIT program on here that we're not going to go through on this one, or I didn't expect to. I mean, maybe another video. I don't know if I've done SIT on the Model 60 before. And then here is the UNPC, and I don't have this loaded onto the hard drive. I think the diskette drive that is in this unit will work. It is connected. I think when I put it away, and I've got the ESDI controller and big honking drive in there that we'll probably hear power up. But let's go through, and I want to run the program first, and then I can get into what I have to show on the planar. So we're going to get this in, get the cable out of the way. And I don't know be, okay, that's seated. Probably tighten that thumb screw a little bit. Okay. And whether I want to show the same thing I'm seeing up on screen here, I guess this doesn't really show into the Model 60, but I've got it, let's do, okay, I guess I have to do it on the computer. I have to go through. Okay, so there's kind of looking in the Model 60. See my big old copy machine back behind there. Okay. And I'll use this and I'll zoom in on the Model 60 planer that I have out here after all this. But let's go through. I've got it connected up. Get to hear that okay. Okay, and as expected, and I guess I should get the that reference diskette in there. Let's see how this comes up on the screen. Okay. We can hear that hard drive. And I do have the UNPC books up here on top. I'll be giving page numbers and even showing those. I need to actually feed the content of these pages over to Major Tom. It's laid out real well. I'll show it on camera. And so we can get up a web page on this and start to identify some of the things. Let's actually go to a 4x3. And I want to... There we go. Get that over to the side. Since we do have the ADF on there for that memory adapter that we have on the bottom, we are going to, okay, F8, and we are going to enter. I mean, this is a new, fresh battery. I make configuration. And the reason I'm using the Model 60 as an example here is it's a tower version of what the Model 50 is. That Model 50 is the desktop unit. And it has, the Model 50 of course has, and 50Z have those 4 adapter slots. And we saw in the previous video, the regular CMOS area is enough to store the configuration for 4 microchannel adapters, but not for 8 like the Model 60 has. And so the Model 60 had to add on more non-volatile RAM storage, additional CMOS area, that extended CMOS area that Microchannel uses, 2 kilobyte of memory space for that configuration. And it saves all 8 adapter slots also within that extended CMOS area, in addition to the 4 first ones that are stored within the regular CMOS. And we'll look through that. I'll demonstrate that just like we saw on the 50Z. And I left the reference diskette in there. It's interesting it didn't nag me on time and date, and maybe what it had is the configuration I had before. But I added that new memory adapter, and so maybe it has the time and date still set correctly here. No, it reverted back to 1980. We are back in the 80s. So, today is 28th. Okay, not really critical. Man, it's getting late here. I'm started on a video, and I should be but like I say, and I was a little bit busy and had to get things up there and get them staged for what I could. Okay, so we've got everything to the system now configured, and I don't know if it'll necessarily have the driver for that memory adapter, and we did see that on the 50Z, and it does have an EEPROM to it, so we'll just have to see what it does. Here we should be booting from the hard drive, and I'll probably just copy the UNPC files over to the hard drive of the system anyway. I don't believe I have them on the system. So right now I haven't gone through any pauses or anything else like that. I'm hoping that we're not going to run into a super long video here. Okay. And we're counting the I didn't. Let me just see what it says. Okay, so it's running the HiMem.sys. Despite all that, just based on the. I've even got where evidently I go through and load. Okay. So yeah, we've got other stuff on there. Don't have UNPC on there, of course. So we're going to do make directory C:, and I don't have to give it all the path. I could just said UNPC. Okay. We're going to go through and we're going to change directory to the UNPC directory that we just created. We're going to say copy actually I'm going to say dit.dit, my wildcards, just copy everything on that diskette to this UNPC directory. We should be able to move through this pretty quick. See, there's our CMOS view program. Even, the assembler file source that Frank Van Gilluwe did. Gilluwe. Again, he gave me the correct pronunciation of his last name. Author of the Undocumented PC, that UNPC book that I referred to. I gave the ISBN numbers for the first and second edition. Before on the 50C video, I can undoubtedly provide it here because I'm going to give page numbers of where this information is. And I've said before, my second edition book, I do have Frank's autograph within that book. Somehow, some way, came up with the autographed copy. Kind of neat, I think. That's maybe nerd cred or something. I don't know. Insufficient disk space. Okay, are we that? Okay. Do we have enough of the UNPC? Because I want to run it in the graphical. Yeah. Okay. Okay, I'm going to do a pause. I'm going to decide what I can get rid of on the system. I think we almost have all the files, but we'll see. I'll be right back. Okay, I had MS-DOS 6.0 in that old DOS.1 directory. So I just went through, swiped all the files. I can rebuild MS-DOS 6 on. I don't need those files for anything, and the this system has been upgraded to 6.20, and so we've got uh, 6 megabyte free now, so we should have the contents. And that, as I say, I think we're right to the end. I don't want to necessarily re-copy. Yeah, we're almost to. And so what we'll do is we'll do a dir a and with them being in order, see, we have that UNPC. We can just do copy a UNPC. Well, I'm going to go through and I'll pause the video again for moving those last 5 files to the hard drive. Okay, easy enough to do that. We're going to start the UNPC program up. I will turn around to face the display. I don't know why it still has that. I think that banner for the what mode I'm in, that'll go away. So we're going to go down to the view CMOS RAM contents. And again, I kind of wish, and I know it loaded a mouse driver. And I told Major Tom I'm going to go through and I'm going to update the text that's displayed. That's just a text file that I can go through and update to the to make it more specific for that vendor specific entries. We can get that to where it's listing more of the microchannel stuff. Okay, so getting down again to 32 hex in that leftmost column, the date century byte, MCA checksum low. You know, that remember we've got to get down to hex 37 or 37 hex is where that century byte is actually held on a microchannel or of any PS2 system, I guess, and any system that followed PS2s from other vendors like those NCRs and things like that we talked about. Now with the MUL 50, and I've got the first edition opened, and we are back on. I think it started like on 19 hex. Okay, so 19. Okay, we had it there at the top. It's probably the best way to look through it for it. Okay, and this should hold the, and that's interesting for all that, because 19 and 1A should hold the adapter card ID for slot 1. And it doesn't look like that's uploaded. And we have all the other microchannel slots empty. So maybe with the extended microchannel, the extended CMOS for storing that adapter information, maybe it doesn't use the regular CMOS. I thought it was mimicked for those 4 adapters, the 4 lowest adapters, 1 through 4, was mimicked. It was in regular CMOS, but then it was mimicked in the extended microchannel CMOS as well. And let's go, and since we only have that memory adapter in slot 1, and then we have the ESDI drive adapter in slot 8, and that is not going to be held in the regular CMOS for an adapter slot up that high. So this is on the first edition UNPC book, to follow along at home, basically. That's looking at starting from page 758. And looking at the 19 hex register or offset in that regular CMOS. So what I will do is I'll page over, and I'll give the page number, and I'll show it up close because I like it better on the first edition, but I'll also show the second edition and give the page numbers for it as well. And you like all my okay, so we will go. I don't know if I want to. I could normally flip back to the camcorder for really close-up shots, and I will anyway later on. Let's see how this shows up on the webcam here, though. This is the, well, what the heck. We're going to go over to, and I'll have to work with bring in the screen. Okay. And remember, I shifted over the screen, and I'm in the 4x3 format, but this will easily, and I can easily see with the display behind me to see what's showing on the screen. So register summary, extended microchannel CMOS memory registers not included on the list are generally unused, but may be used in feature systems. There's meaning where there may be some empty positions within this 2 kilobyte of space that are not normally used by by all the IBM PS2 systems that were out there. Okay. And since the function is identical to an earlier described register in the list, below, for example, disk 1 registers are identical to disk 0 registers other than the disk number. We're just going to get through. So this is the contents of that extended microchannel memory. Just going through. Now I'll show this, and I can bring up this information again as we look through on the system to see that. And we're in chapter 15, CMOS membrane real-time clock. There's all your card slots, and remember, that's starting at card slot 0. What they're identifying, computer-based, 0 through 7 being your microchannel. And then there's checksums is what those CRCs are. Size of extended memory, maximum cylinders, maximum heads, all the hard drive information. At the very end of it, you get into the total microchannel slots. I've referred to that before in previous videos. It talks about the postcode for the CMOS presence test. Be interesting to see what value that holds in there. I've actually penciled in, as you see, the 190 hex is the register that normally holds the CPU type, and then 191 hex is CPU revision, and that's 386 SX or above. The 286, like we have for the Mul 60, I don't think that that'll be populated for everything I know, but we will see. And then it jumps from, after the 191 to the that 389 hex probably being up close to the 2 kilobyte of memory, the end of that, and it has about the error logs, and there may be more error logs that are error logs on the next page. As you can see, 772, and like I say, all those wonderful little starburst labels, I guess I have as bookmarks. I'm playing the poor boy there. And so it has asterisks, and then it explains in text, and we see these entries in here, and that was what I was reading a little bit before. This register holds the adapter card ID for slot 0, least significant byte, blah, 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 and then kind of explains, and then there's the POS bytes used, the amount of POS bytes, those values that are held in that non-volatile RAM to configure the adapters. So we're going to go through and we'll just go through all that text and explains. We'll go through and we're going to put the first edition away. Get out the second edition. And this is, let me get to the right page. Okay, and we went through earlier, and we went down all the way to 19 hex. And this is the layout of the second edition. This is on page 908. And we didn't see that, that configuration in the regular CMOS space. So we'll leaf over to a bunch of neat information, even for other vendors other than IBM. Okay, so even talk about the password. Okay, extended CMOS, yada 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 yada. Okay, and it talks about port 76. That's the port that port 74 through and 75 and 76 being used to read those into the extended CMOS. And there's the start of the same table basically for the slot 1. It's got all the information on the next page. Same table, and you can see we were on page 945 before. 94 continued on 946 and 947. All the way that same text that we saw before. So I'm going to leave up for this particular page. And as I say, we're kind of looking for, we're going to get into I'm using that clear click and with the remote. Nice little way to switch between the sources, whether it's HDMI from my camcorder or VGA output full screen, displaying that really nice. So as I say, I'll go through and update that the text file that shows all the identifies all the different CMOS register offsets. So we're getting up to the end. Okay, so there's our microchannel extended CMOS memory. And now we can see with that starting, register 0 and 1, we have that, and remember, its most significant byte is in the later positions. Least significant byte first, most significant byte next. So the adapter ID of what we have on adapter slot 1 is F7FE. And then it has the POS bytes, and if we ran the system information tool, it would show that those are the that there's 2 bytes that are used for the POS settings, is what I think I remember from that. So read that again. Yeah, it says POS bytes used, and then POS byte 2, POS byte 3, POS byte 4 for the adapter, POS byte 5 if whether the adapter uses how many bytes it uses of those POS registers, but there are up to POS byte 5 available for that. And then in for 2.3 hex, that starts for the 2.3, and ultimately we're moving down after all those zeros that are filled. We're moving down to where it has that FF, and then FF. And what that's showing is there is no adapter in slot 2. We would go through, and of course it's showing then 0, 0, and then that 0, 1, and I don't know what that 0, 1 value would mean in this case. But we'll get down to the row for adapter slot 3 being in that FF for no adapter being present in that slot. We get into the FFFF in that row 0060 hex, being that that's up at the 969 or 6A positions for, I think we said adapter slot 4, right? And then we have adapter slot 5. We have adapter slot 6, starting up at that 008F location. Okay, and then we have the 00D2 and 00D3 positions for the slot 6 as we have it, and then so all those adapter slots are vacant. Then we get to, and I identified earlier, the 0F5, yeah, 00F5 and 00F6. For the adapter ID there, and I would have to, and I believe that is that DDFF is ultimately the Microchannel ESDI drive controller. And I know I do have, where I'll bring up the MUL 60 planar, the web page for that. I can look through and see. In fact, let me look real quick on my system. We're going to drill into, and I already know where that page is at least. Okay, PS2 family. Sorry, I'm doing this off screen. Let's do storage adapter, IBM, Microchannel ESDI, MFM controller. Okay. And what is the... Okay, yeah. So DDFF is the adapter ID for that ESDI drive controller that we have in slot 8. So, and then it's got the following. It's using 2 bytes, if I read that correctly. It's got that 5517, and those are hexadecimal values still. that it uses for the configuration of that ESDI drive controller. So that is the layout, and we've learned now, like I said, going into this video, I was kind of a little bit blind. I expected the first 4 adapter slot positions to be held in that regular CMOS content area. There's space in there. It defines, and it defines that it's mimicked between the 2 spaces for those first 4 adapter slots. In the case where there's that extended CMOS for the microchannel stuff, and we learn now that that doesn't look like it's the case, and so a little bit of learning there that we're doing. So we've covered, all that. We can look down just to be kind of complete here, and we can see kind of a filling, byte filling process for some of this area where it's doing the 00FF, 00FF, 00, so on and so forth. And we could get down to the error logs and things like that. I just wanted to show there so at 18E hex, we have the total MCA slots. So 18, putting that on the topmost row, and so E. So we're looking at the second to last column where it has that 08. So there are 8 microchannel slots that this system is identifying, and then for the 018F position, it just has an FF that's filled in there. It doesn't use that. Skipping down, and I want to get to the. And I made the note in my first edition book. I didn't make it in the second edition book yet, but remember that 0190 position is supposed to be for the CPU family when it's a 386SX or above, and like it has a 2.3 in there for the and that's that CPU reset signature that's held in this area. And then the 0191 is the kind of the revision level or the model number, I think, as they identify it. That, like for the 386SX and the 386DX, they do stepping values. You'll see 01, 02, 04, 05 in that field. The 46 family expands a little bit more. We've covered that in previous videos, but I'm just wanting to show for the 286 level, of course, that's not populated. There's not any form of a CPU reset signature for that 286 CPU, or at least it's not saved away either in this extended CMOS area. I'm really sure from reading over the Intel manuals and everything else, Intel did not implement a CPU reset signature for the 286 CPU. The 386, and that being split later on into the 386SX and 386DX, was the first time that CPU reset signature was employed in the CPU for the start of the Intel things, that what later became the CPU ID instruction was implemented later. So we get to see, a good, bunch of detail here. Who knows? It doesn't cover some of these, what some of these offsets are storing. It looks like backfilling a little bit like we saw with the MUL50Z in a way for those blanked out areas. And who knows, we may even discover some stuff that's not identified in the book of places that it stored information for this, because some of these extended CMOS registers are not identified what the contents would be, but they're clearly populated with information. They're holding some value in there. And we get up to 389 hex would be for the bumping everything here. Would be for the error log number 0. So this is where the let me get to that being the top row, and that looks good because we don't see, it all looks like it's all zeros in there. We don't see any information here for the error logs. It looks like all that space that the error log would be is just zeroed out. And then we get into, further space, and this just looks like backfield information, but I mean, it's you can even see some of this is changed. It does have values within this these areas for this 2 KB of space that it has. We're getting down to, okay, so apparently that's the and that would be the end of things that just off screen for that space, that 2 kilobyte of space. But we can see just how much storage that is, how much has been used, or how much is identified in the UNPC book for what is stored in that. And we see where those, again, I'm wishing for the cough switch. We see where those adapter IDs are stored within this extended CMOS area. And that's what I was really looking to display, because again, the 50 and 50Z models of the PS2 do not have this extended CMOS space. So lastly, what I need to do, and we're still a little bit below 50 minutes. I don't want to brush my mic too much. I just swapped batteries in my mic, because last video it was blinking right at the end. I was actually lucky. I think even the microphone was a little bit staticky at the end of that video too. It's been my wireless mic has been behaving pretty well otherwise. So I wanted to go through, and I may have to go through and realign. In fact, it's probably no harm leaving the system running. Okay. And I have to decide whether I need to realign anything. So this is the Mall 60 planar, and this is the position it'd be in. The power connection at the top. All your ports there on the back. VGA chip. And of course, I don't have any memory in the 30-pin SIM slots. This is the, and we'll return up into this area in just a moment. This is the diskette drive connector, floppy diskette controller. Getting down, we have the ROM, the BIOS, and I've of course dumped these images. Some have, it's interesting, some have a label and some don't. It's, the FRU is silk screened on there. I think what we're having, normally this does I don't know if I want to turn on my ring light. I think it's just a problem with the lighting is the reason that this kind of looks so funny on the screen. I mean, the camcorder is able to zoom in. So here is the battery connector, speaker and battery connected to this lower corner. No CPU or floating point coprocessor that are on this board. Even though the battery connects here, and runs the non-volatile RAM or stores that non-volatile RAM configuration, it is back up here. This is that, a squared version, a later implementation of the Motorola real-time clock chip, that MC14618. I'm doing that by memory. Chip. In fact, I think what I'll do, I'll do my boom, I'll do my zoom. Okay, so as I say, that's the diskette drive connector. There's our regular CMOS real-time clock and CMOS for the 64 bytes of regular CMOS that it has stored there, and it does have an EC change. I don't even have to see what pins those are, what that does of that, and I don't know if that's on the planer that's in this system or not. Don't blind anybody. Okay, and the planer that is in there is got that same EC of that little loop, that yellow wire loop. So the extended CMOS, you ask. Okay, and if we can get, and I think, like I say, the clarity is mainly in just the lighting that I have here that I'm using. It's night. I think in daytime this would probably show up a lot better with the natural light reflected through the windows and everything. But this is the chip, this ZM5. That is the chip that holds the extended CMOS non-volatile RAM. And so there's ultimately power leads that are coming up, and probably close to where the Motorola chip is here. In fact, I don't know if I have room to spin. No, not the way I was looking to get them both on screen. Bump on my diskettes. Okay. So there on the left we have our just looking at, yeah, you can see how me putting my hand over really reflects the light, and that regular CMOS chip, the Motorola chip, shows up really great with that view, and then the extended, CMOS chip in that ZM5 position being right there. So that's just where they are on the planer, and I got to get the information. We can get up a web page a little bit more on the contents of that extended CMOS area. But that is where it's demonstrated on the Mall 60. So, if you enjoyed this video, and we're going to come up 55 minutes, maybe a little bit more of this, click on that like button if you enjoy this video, if you enjoy the content, if you enjoy what I'm showing, for these videos. And by all means, comment. What about my delivery style? What about, give me some feedback. But because this video is so impromptu. I mean, it was a matter of probably even an hour or two ago. I didn't know that I was gonna do a video this way, or starting to think on that, and just had the stuff and just started latching onto it, load it up on the bench, and give it a go. And so some of this stuff I line out, 50 and 50Z, and then put in 60, and just a quick mock-up of that page. I'll include this information in the video description. Let's finally get, there is the page on the Ardent tool for the Mall 60. Has the planer in that lower left-hand corner of the planar diagram. That's where the speaker battery connection is. And over on the right lower corner, as this planar is oriented for the diagram, we see that it identified for the and probably for the list here. So we have the ZM5. Okay, and the ZM5 giving the information for the chip that's the extended CMOS, and then the ZM6 showing where that Motorola chip is for the regular CMOS in that diagram, next to the J1 for the diskette controller. But that's the limits of that Model 60 page. It's up right now. And Thompson been doing a great job of filling a lot of this stuff and the information, and going through and just getting that web format. And he's even had to change the style and keep up a little bit and everything else. But, doing a great job. I mean, he deserves a lot of praise for what he does with that. So that is the Mall 60 page, and indeed I can link it in the same way. And I'll link in the the ISBN numbers for the books, the Undocumented PC books, UNPC, by author Frank Van Gilluwe. And so people, if they're interested in those books, they can go out there and purchase them, please. I don't think he was... in my recent contact with Frank, he says I'd even forgotten about some of that stuff, the books and everything else. But that's it. And there's going to be more stuff coming like this with my for the content of this channel. So click on that subscribe button, get those notifications that I put when I put up a new video. And that is all I have for now. This is IBM Museum. Thank you.